Hey Finxters, and welcome to today's in-depth tutorial on how to write clean code. In particular, I have compiled 7 tips to write clean code. This is part of a book project from my upcoming book, From 1 to 0, which is a book full of coding tips. But the book is not released yet, it's just a chapter, and I just created the content. I thought it may be nice and helpful to share this content with you. Okay, so let's dive right into the content. You may ask, why writing clean code? And maybe I start with a story. I learned to focus on writing clean code the hard way. And one of my research projects, for example, when I studied computer science as a doctoral researcher in distributed systems, was to create a distributed graph processing system. And if you know anything about distributed systems, you know that creating distributed systems is really error prone. It's really hard. There are a lot of messages. The complexity can be really overwhelming. And so my code had thousands of lines of code, and many bugs were popping up frequently, and I didn't make any progress for weeks at a time, but still working the whole day on the code, and I didn't know. It was very frustrating. I didn't make any progress. I invested a lot of time and effort into it. In theory, the concepts I developed sounded great and very, very, very convincing, but practice got me. And finally, after months or so working full-time on the code base without seeing any encouraging progress, I decided to radically simplify the code base, and I started to use libraries instead of code functions. I removed large code blocks of pre-major optimizations. I removed code blocks that I had commented out for a possible later use. I refactored variable and function names. I structured the code in logical units and classes. And after a week or so, I managed to make progress again, and my frustration quickly morphed into enthusiasm again. I had clean code had rescued my research. So this is my personal story, and this is how I learned to create clean code, especially if you have a non-trivial project. This is really critical, and if you work with other people on your code base. So your complexity can really kill you, and complexity kills your productivity, your motivation, and your time. And most of us haven't learned to speak in source code from an early age, so the complexity can quickly become overwhelming. So therefore, it overwhelms our cognitive biases of understanding code bases. And this is why, if you write quick and dirty code, you see here plain and simply in the graph. If you write so the x-axis is the number of lines you have already written in your code project, and the y-axis corresponds to the time per line. So the time you have to invest to write one additional line in your source code. And you see, the more lines of code you have already written, the more time generally it takes to add another line to the code. And this is because of, there are many reasons for this. One of them is backward compatibility. So every line you add can add new bugs, can add new dependencies in your code. So you need to resolve them. You need to make sure that every new line doesn't destroy the functionality you have already implemented in previous lines of code. So usually progress slows down over time, but if you have quick and dirty code, it slows down like exponentially. The more code you have already written, the more. So if you just quickly write a code, you don't use comments, you don't use clean code, then progress will slow down. Initially it can make sense actually to write quick and dirty code if you have only a few lines of code, say 50 lines of code or so. If you have a very small project, you can write dirty code and nobody will die because of it. But if you have non-trivial code project, it always makes sense to invest more time initially in order to make the project more scalable and to reduce the number of mistakes that follow down the line. Good. So I hope that you are motivated to actually mitigate those problems. There's a simple solution. You should write simpler code, and it is less error prone. It is less crowded, easier to grasp, easier to read for humans. It is more fun to read and write as well if you write clean code. So I hope that you are properly motivated to write clean code by now. So let's dive into the principles to write clean code. So the first principle is called "you ain't going to need it." And this principle suggests that you should never implement code if you only expect that you're going to need its provided functionality someday in the future. So if you only expect that you need some functionality, then you shouldn't write the code because you ain't going to need it. Instead, write code only if you're 100% sure that you need it. So code for today's needs and not tomorrow's. So it helps to think from first principles. The simplest and cleanest code is the empty file. And it doesn't have any bug, and it's easy to understand. So go from there. What do you need to add to that? So you have maybe you have already learned about the minimum viable product. This idea is really it's to minimize the number of features you pursue in your code, and by doing this you'll harvest cleaner and simpler code than you could ever attain through refactoring methods or all other principles combined. Okay, so if you write less code, you have less complexity, you have less stress and fewer bugs, and you have more focused code and you make faster progress. So the first principle is don't create unnecessary features, unnecessary complexity. The second principle to write cleaner code is the principle of least surprise. So this is one of the golden rules actually of effective application and user experience design. So for example, if you open the Google search engine, the cursor will be already focused in the search input field so that you can start typing your search keyword right away without needing to click into the input field. Okay, so this is not surprising at all. I mean, if you open Google, you can search right away without moving the cursor anywhere. But this is exactly the principle. It's a principle of least surprise. Clean code also leverages this design principle. So say you write a currency converter that converts a user's input from US dollars to renminbi, which is the Chinese currency. And you store the user input in a variable. So which variable name is better suited now? User underscore input or var underscore x. I mean, if you open the code shell and we want to process the input from a user, so would we use this variable name or would we use this variable name? I mean, it's obvious, yeah. So this one is least surprising, so therefore we would use this one, yeah. So this var x would actually surprise us somehow, and therefore this choice is much better. Good. So the next principle is don't repeat yourself, or in short, DRY. So this is a widely recognized principle that implies that if you write code that partially repeats itself, or that's even copy and pasted from your own code, this is a sign of bad coding style. A negative example is like the following Python code. I can show you an example. So say we have this Python code. This Python code clearly violates the don't repeat yourself principle. Yeah. Why? Because we have this print hello world, the same code again and again. So the code repeats itself. There is some redundancy in the code. So therefore, we must do something about this. So how can we reduce complexity of this code? How can we make this cleaner? By using a simple for loop. Okay, so we iterate 5 times. We go 5 times over the loop body, and the loop body is simply to print hello world. So this is a principle of don't repeat yourself. So always, if you see in your code some repeating code snippets, then just think about how can you avoid the repetition, and this usually hints into the direction where you should go with the code and how to write cleaner code. So the principle also shows you when to create a function and when it isn't required to do so. So say you need to convert miles into kilometers in multiple instances in your code. So again, having an example, say we have like a variable miles, a variable kilometers, and now you do the conversion here, yeah. So we multiply miles with 1.60934, and this gives us the kilometers converted. And now we have some other code in between, and then again we use the conversion technique here. So we calculate 20 miles and we multiply it with our conversion conversion number, basically, yeah. So and this is actually a bad example. So the output will be like some converted numbers, but this is a bad example. Why? Because we use this magic number multiple times in our code, and it is actually we have repeatedly used the same value. So what is a better way of doing it? yeah, I mean, a much better way is to actually introduce a function in the code. So now we have a function miles to kilometer. We pass a variable called miles, a value called miles, and we multiply it with 1.60934. And now we don't have this magic number anymore in the code. We just call the function miles to kilometers. It's very explicit, very understandable to readers in the code. We don't, I mean, even if we need some more refined accuracy of our conversion, so say we would like to add another 3 to this to make it even more precise, then we can simply do it once in our function, and we don't have to update all occurrences of the same code. And this is the benefit of not repeating ourselves. So the principle is don't repeat yourself, and by avoiding the repetition, you write cleaner code automatically. Okay, so the next principle is write code for people, not machines. So the main purpose of source code is to define what machines should do and how to do it. But yet, if this was the only criteria, you'd use a low-level machine learning language such as assembler code to accomplish this goal, because it's the most expressive and most powerful language. I mean, you can do anything in assembler code, right? But it's not the best way of writing code actually to write very clean code. So the purpose of high-level programming languages such as Python is to help people write better code and to do it more quickly. And our next principle for clean code is to constantly remind yourself that you're writing code for other people and not for machines. So if your code will have any impact in the real world, it'll be read multiple times by you or a programmer that takes your place if you stop working on the code base. So always assume that your source code will be read by other people, and what can you do to make their job easier? And we can also put it more plainly, what can you do to mitigate the negative emotions they'll experience against the original programmer of the code base they are working on. So code for people, not machines. So you may ask, what does it mean in practice? Give me some code to show me what you mean actually. So let's have some code. See the following example. This one is a bad example. Yeah? So we have some variable names xxx, yyyy, zzz, and then we iterate, calling our loop variable I, over all values from 0 to zzz excluded, and we do this magic computation. So think about this. What does this code actually do? Probably it takes you a while to figure this out, what it does. But now let's have the same code that we have written for people, not for machines. It's the same code, semantically equivalent code, but now we have written a code for people, not for machines. Okay, and you see we have some initial investments. We have a yearly return of 10%. We have 10 years. We go over all years from 0 to 9 included, and then we calculate simply the current state of our investments. So if you run the code, we see the current states of our investments. So our investments grow from $10,000 to $23,000 over a period of 10 years using the growth rate of 10%. So it's very easily understandable by human beings if we have written the code this way. If you have written the code the other way, like this way, it's actually not understandable by humans. So you should always write code for humans first and for machines second. So there's also a good quotation by Martin Fowler, who is the international expert on software engineering and author of the popular book Refactoring. He argues that any fool can write code that a computer can understand. But good programmers write code that humans can understand. Okay, so this is really a critical principle. So let's dive into the next principle, stand on the shoulders of giants. There's no value in reinventing the wheel. Programming is a decade-old industry, and the best coders in the world have given us a great legacy. A collective code base or database of millions of fine-tuned and well-tested algorithms and code functions. And accessing this collective wisdom from millions of programmers is as simple as using a one-liner import statement. I mean, why on earth shouldn't you use this power and shouldn't you leverage this power? And by doing this, I mean, besides being very easy to use, using a library code is likely to improve efficiency of your code base because the functions have been optimized by the best coders in the world. And they are easier to understand, take less space in your project, and also reduce the number of bugs in your in your code base because they are already well-tested code functions. So if you use libraries, if you use libraries and instead of writing the algorithms by yourself, you have many advantages. You have much cleaner code, more efficient code, less buggy code, code that is easier to read and understand, and code with fewer bugs. I already said this. So so this is why excellent coders are 10,000 times more productive than average coders. It is not usually because they can write 10,000 times faster than average coder. It is because they know how to stand on the shoulders of giants, how to leverage other people's work, and how to leverage the whole knowledge, the whole wisdom of the programmers who lived in the past ages and have already invented the wheel, so to speak. Okay, so this is why you can do a simple clustering call in 2 lines of code. Yeah, so if we import k-means clustering algorithm from scikit-learn library, running the k-means algorithm is as simple as 1 line of code. I mean, if you would write this in your own code, you would use 100 lines of code. You would use the whole day to figure it out, to test your k-means algorithm and everything. And then you would have an algorithm that is not as efficient as this algorithm, and it takes much more space in your project. I mean, if you have a practical project, you should always use the functionality. And actually, if you think about this, programming is just like this. Even using a high-level language like Python uses functionality from low-level functionality from assembler compilers. So, for example, your Python code will be compiled down to like virtual machine code or bytecode, and this bytecode is then compiled down to machine code and is executed on your computer. So therefore you always have this chain, this compilation chain. You always leverage, you always stand on the shoulders of giants. So why not doing it also like 1 level further on a very high level, stand on the shoulders of giants, leveraging the libraries of coders before you, and therefore making fewer mistakes and writing cleaner and better code. So this one is a huge technique. You should really internalize these techniques. Always try to use other people's code before writing any code yourself. Okay, the next principle is called use the right names. So your decisions on how to name your functions, function arguments, objects, method, and variables uncovers whether you are a beginner, intermediate, or expert coder. How? In any programming language, there are many naming conventions that are used by all expert coders. And if you violate them, it immediately tells the reader of your code base that you've not had a lot of experience with practical code projects. So the more such tells exist in your code, the less serious will a reader of your code take it. And there are a lot of explicit and implicit rules governing the correct naming of your code elements. And these rules may even differ from programming language to programming language. For example, in Java, you may use a variable called camel case naming. Hello world, something like this. So you may do something like this in Java with a camel case naming, but in Python actually you don't use camel case naming. You use underscore naming. So you separate different words with an underscore rather than the camel case what you would do in Java. Okay, so this is just one example of naming conventions that are different in different programming languages. Therefore, it doesn't make sense like to throw them out explicitly, what are the conventions, because they may change from programming language to language. But what you should do is to Google it once. I mean, invest 1 hour today, Google it once, read over the naming conventions of your programming language that you prefer. So for example, the Python naming conventions are given with in the PEP 8 standard, and just go over them, read over them, and then try to incorporate them. And also, like an expert tip, what to do is to read other people's code on a regular basis. So go to GitHub, seek out projects from expert coders. There are myriads of projects from expert coders, and go and just read over them. Just seeing and getting these impulses from expert coders will make you a better coder. So it is far better to reduce the number of surprises in your code. And there's no value of in surprising other coders by choosing unconventional variable names. Okay, so let's maybe have a few examples. What are some good naming conventions? For example, choose descriptive names. So say you create a function to convert currencies from US dollar to euro in Python. Then we call it US dollar to euro, and then we pass in the amount we want to convert, and we return something, yeah, which we do with the amount, say something like this. Okay, so if you create a function, this function is easily understandable. We have used descriptive names, so we convert US dollar to euro, we use amount, and we simply convert it like this. Okay, so it's very understandable. This one would be a good naming, but then we could also use this one. This is a bad naming, yeah, because we have now we have chosen non-descriptive names. So this is the first tip to write more better names. The second tip is to choose unambiguous names. So maybe you think that this one, dollar to euro, is a good naming, and it is descriptive. It is very descriptive naming, but it is ambiguous, because dollar, I mean, there are 3 types of dollars at least. There's the Australian dollar, there's the Canadian dollar, there's US dollar. So which dollar are you talking about? Maybe it is obvious for you as a US person, but there are also other persons. I mean, for an Australian, it may be obvious as well that we talk about Australian dollar. So therefore, this one, you should always choose unambiguous names like this one, US dollar to euro. And then the next one is to use pronounceable names. So another example is, for example, if you have a customer list, and then we put in Alice, for example, something like this, you will see this in some code bases, okay, but it's not pronounceable, and therefore it takes a space in our precious attention. Because we cannot pronounce it, it takes a space, and we have to actively think about resolving this pronounceability issue. So therefore it's much better to just take the extra space and write it out, customer list. And then a reader of your code, it will not even perceive that there's some problem. It's very smooth reading progress. He will not be surprised. He will not have to spend valuable attention on deciphering the variable name. Another big one is to use named constants rather than magic numbers. And we have had an example previously, but maybe we have it again. So say you always convert in your code like euro. So we have some number, say 10 US dollar, and we convert it to a euro amount by multiplying it with 0.9. So this 0.9 now is a magic number, and maybe we have it multiple times in the code. So say euro 2, and now we have 20 US dollar. We again use our magic number to convert it. So this is a bad coding technique, because we have now a magic number in our code. Nobody understands where this number comes from, okay? And if we have to change it, we have to change it everywhere in the code. And maybe, I mean, we cannot search for 0.9 and replace all the 0.9 occurrences, because we may have used 0.9 for other instances in the code. So therefore it's very unmaintainable, very bad style to do this. So what is the better way? The better way is to simply use the following technique. So we have a variable called conversion rate. We define this variable once in the beginning. Usually you do this with this capitalized letters, and then we set it to 0.9. So this is our conversion rate, and now we can simply use the conversion rate always in our code. So at different instances in our code. So now you see if you change this number, so if the conversion rate changes, then we simply change it here once in our global magic number variable conversion. So these are some naming conventions again, but to pick the conventions up, it's best to Google them once. For example, search for Python naming conventions. Just study GitHub projects from expert coders in your field, and you will become accustomed to these naming conventions. Okay, so let's dive into the final seventh principle. It's called the principle of single responsibility, or single responsibility principle. It means that every function has one main task. A function should be small and do only one thing. And it is better to have many small functions than one big function doing everything at the same time. This is also called the God class often. In many cases, you have one class to rule them all, to do everything. The reason is simple. So this encapsulation of functionality reduces overall complexity in your code. So as a rule of thumb, every class and every function should have only one reason to change. And if there are multiple reasons to change, multiple programmers might actually decide to change this function at the same time, and this may cause some problem. So this means that you have mixed too many responsibilities in your class, and now it becomes messy and cluttered. So let's consider a small example again to show this issue. So say we have a class called book. It has a constructor, and we have some attributes like title, publisher, author, and the page number. Okay, so this is just some information about the book, and this code is used to create your own ebook reader. So maybe this could be the ebook reader software. And now we have one book. This is a particular book, and we show the page number. And here we create this book. It's called now the variable Python one-liners. This is my book, by the way. If you want to get the book, I just plug in this advertisement. Check out the book Python one-liners. I think it's a great book, and it's greatly rated on Amazon. You can just Google it, Python one-liners, and you will find the book. Good. So we create the book, and we now print get publisher. So we have a few get methods, or called getters, like here get title, get author, get publisher, and then we have a function next page. But we also have a function print page. Okay, and here we but actually, if we call the function next page, we set the current page +1. So this means that the reader has just maybe pressed one button, and the reader proceeds to the next page. Okay, and then we return the current page. And then we also have a function print page, and this means that you can always call Python one-liners.print page, and this means that the page is now printed or formatted and printed on the screen. So there are basically two responsibilities now in this book class. This book class at first has the responsibility of collecting the information of the book, of modeling the data and the state of the current book. And the second one is to represent the data to the user. This print page function is actually a second functionality, and therefore this class wouldn't adhere. So I mean, it looks very clean, but it wouldn't adhere to the single responsibility principle because this class is now responsible for collecting the data and for managing the data and for visualizing the data with this print page. So what is a better way of how to resolve this? So basically, we can easily resolve this with the following code. Now we have two classes. We have a class book and we have a class printer. The class book has all the same methods as before and the same attributes as before, except one. This is this print page method. And this print page method is put into a separate class printer. And this printer can be used to print many different books. And this print page method now takes also an argument called book. So you pass the book you want to print into the printer, and now it simply prints the book content with the current page. Yeah, so it calls the getter method book.getPage to get the page of the book, and then it prints the book. And if you run this class, you get the same output, but you have actually separated the functionality of printing the book and simply modeling the book in your code. So this would be a better example that would adhere to the single responsibility principle. Okay, so that's it. To conclude the talk, I think the most important principles are that you write code for humans, not for computers. So use meaningful names, use meaningful variables. Structure the code for humans, for example, regarding indentations and stuff. So always think of the coding discipline as you are writing code for other people. You are not writing code for the computer. And if you have this top of the head, sorry, then you will automatically write much better code. Okay, so always think that you write code for other people and make it more readable for them. This also applies to comments and everything. So you write code, you add helpful comments, because comments are not for machines, they are only for humans. Okay, so therefore always write code for humans. I think this is the most important principle. If you can keep this principle always at the top of your head, you will become a much better programmer, and you will do being a better programmer also means that you will write code that scales better. You are able to write like more profitable code, because your code projects will just scale to more lines of code than if you would had written quick and dirty code. Good. So you can also check out my my Finxter email academy. It's called blog.finxter.com/email academy. So you can subscribe there. And in the Finxter email academy, I give a lot of tutorials. So you can choose actually different email courses for free. So everything 100% free. You can also download Python cheat sheets. You get a lot of video content for free. You just click the link of the course that interests you, and then you get a series of emails that actually email lessons that push you further, push your knowledge further, and this is 100% free. So check it out, the email academy. Just put in blog.finxter.com email-academy and you will land there. Thanks for listening to this video about clean code. If you like it, then give it a like and give me a comment. Maybe tell your additional rules. Maybe you find some additional rules to clean code so that I can extend this over time. Maybe create another video with some additional rules to write clean code. Also, if you like to share your stories on where you have written dirty code and where it had actually harmed your productivity, then feel free to do so in the comments. Thanks for watching this video and see you in the next video. Bye.